everyone, welcome back. And today we'll be talking about your sample regression function. So in the previous video we had talked about your function population regression function. In here we'll be talking about your sample regression function and how this is the most useful thing for us while regressing any relationship or while finding or estimating the parameters of any population, because as we had talked about in the previous video also, it's very hard, it's very hard to compute data for the entire population, so we have to deal with samples. So if suppose this is the entire population, so I'll take sample. So I'll take a small sample, random sample, okay, in which every value has equally likely probability of getting a of being a part of the sample, okay. So why I'm taking multiple samples is because a single sample might have a certain bias. If suppose I take data of income, okay, suppose I take the data of income of Indian households, okay. So if I take the data of households from states which are a little well off compared to some other states, then the sample might represent a bias, okay. It might not represent the exact picture of the income of the families, okay. So that is why I take multiple samples, or we take multiple samples, and through multiple samples we try to estimate, or we try to find an average value that might represent the entire population, okay. So this is the game here. This is how we'll be playing. So sample regression function is a really important tool for us. It's the most important tool for us, okay. So mostly we deal with samples only. We have samples of y values corresponding some fixed x values. So in the previous example that we are taking, so we have samples of weekly consumption expenditure corresponding to some fixed weekly income of families, okay. So our task here is with the help of this sample is to estimate estimate the population regression function, okay. So this is the task with the help of sample. This is your SRF, okay. But the only problem is that we draw multiple samples, okay, from the same population and try to fit the sample regression line. So just like we had the population regression line. So this is your population regression line, okay. Population regression regression line, okay. So just like we have population regression line, we have the sample regression line. So we try to fit this sample regression line in the data in a way, okay, that it best represents a population regression line, okay. The problem is that we'll never know the population regression line because we never have the data for the entire population. So we at best can try to estimate it in the best possible way. So estimation is in our hands. So how can we make this estimation more and more better? By taking multiple samples, okay. So we can take n samples and have n SRF, that is the sample regression function, and we have n estimates of your beta naught and beta 1, okay. So this is how we get more and more closer to the population parameters, okay. So that is why sampling is important and multiple sampling is very important, okay. So your sample regression function SRF looks like, or wait, your yi hat is equal to beta naught hat plus beta 1 hat xi. So the value of xi is fixed even for the population and for the sample. So that is why we don't put a hat on xi. Your values of yi are different here for the sample depending on the kind of sample we have taken, and your uh, corresponding to these y values, you have different values of your sample statistic. So in the case of population, your beta naught and beta 1, these are called your parameters. And in case of sample, they are called statistics. So this is the vocab that is different for both the functions. Okay, so just remember that. So if I plot, so I can take multiple samples. Okay, so this is your SRF1, SRF2, SRF3, etc., and try to fit that in the data such that it is closer to the population regression line. Okay, okay, sorry. So this is, suppose this is your population regression function or line, and this is your sample regression line. Okay, this is also line, right? So what is happening here? So if there is this, let me change the color. There is this xi value, so corresponding to xi, this is your e of xi, e of y given xi. Okay, this value, because it's lying on the line, population regression line. So then I have your yi hat value because it's lying on the sample regression line. Okay, and corresponding to xi, there will be a yi value also. Okay, some yi value whose uh, average would come out to be lying on the population regression line. Okay, so what do I see? So let me join this. So I see that this value, this difference, okay, this is your ui. Okay, so this is the gap or the difference between the actual value and the expected value of y given xi, and this is your ui hat. So this is for your sample, right? So for the sample given xi, the actual value is yi, but the expected value is that is lying on the simple sample regression line here. Okay, so this is your, and this gap represents your ui hat. Okay, so this is the graphical representation and it helps you understand the notations in a better manner. Okay, so yi hat is being represented by this function. Okay, here. So so I can write now, like based on the figure that I've shown, that yi is equal to beta 1 plus beta 2 xi plus ui. So this I know, this is the population regression function. Okay, then I have yi equal to beta 1 hat plus beta 2 hat xi plus ui hat. So this is coming from here. Your yi is basically your yi hat plus ui hat. Okay, so this basically is representing your yi hat. So yi is equal to yi hat plus ui hat. So this relation is true and it holds for a sample regression function. Okay, so I hope this notation and this relation is clear, and I hope you understood what sample regression function means and what its importance is and how it is used to estimate the population parameters. Okay, so we draw multiple samples, and based on the values or the estimates of beta naught and beta 1 that we have, we take an average of those values and try to estimate the population parameters based on that. Or that is what is the estimate of the parameters would be, that average of all the sample averages. Okay, so this was about a sample regression function. We'll meet again in another video. Till then, take care.